One of the SwiftUI questions I've been asked more than any other is this: how do I create a fetch request with a dynamic filtering or sort order? And this question arises because our fetch requests are stored as properties on our SwiftUI views. And so if we try and make those depend on other properties, like a sort order or a filter, for example, then Swift will complain. Now, there's a pretty simple solution here, and I think honestly it's obvious in retrospect because it works pretty much like how the rest of SwiftUI works. We want to try and carve out some functionality into a different SwiftUI view, then inject values into it. And I want to show this to you with some simple example code. So I've put together what I think is the simplest possible example we can. We'll add 3 singers to core data, then use 2 buttons to show either the ones that start with A or the ones that start with S. And so, in your core data model, start by making a new entity in here called singer. Then give it 2 attributes. One will be first name, one will be last name. Both should be strings. So string here and string here. Now I need to go ahead and bring up the data model inspector with singer selected and change code gen from class definition to manual/none. We'll make it ourselves, and then go to the editor menu and choose create NS managed object subclass. For that, next, and that one, next, and then put it inside the correct folder like that. So now we've got a little singer class we can customize if we want to, and once we've done that, I want to open up the core data properties.swift file and add 2 properties to make it easier to control the string optionals. One will be wrapped first name, a string, and that'll send back first name, nil coalescing, unknown. And second one will be wrapped last name, string. And again, it'll be last name, nil coalescing, unknown. We might, of course, get the famous singer unknown, unknown, but let's hope not. Anyway, on to the real work. The first step is to design a view that will host our information. Like I said, there's going to have 2 buttons, show me A or show me S, to control the way it's filtered, show the A singers or the S singers. But we'll have an extra one to insert some example data so we can see it all working correctly. So we already have in here our import for core data plus our managed object context we want to work with. And I'll just get rid of this sidebar here and put it up the canvas. It's going to play ball perhaps, we'll see. There we go. We're going to track in here the current sorting. So I'll say @state private var last name filter is A, showing me only the singers whose last name starts with A. Now for the body of the view, we're going to use a VStack with 3 buttons plus a comment for where we're going to place our list shortly. So we'll do a VStack here, then a list of matching singers, then our button saying add examples. And this will say, go ahead and create some singers. So I'll say let Taylor is a singer in the context of our managed object context. Taylor.first name is Taylor. Taylor.last name is Swift. I will copy and paste a little bit. So we'll add Taylor, we'll add Ed, and we'll add Adele. So we'll say Ed's here, and then here, and then here. Adele is here, and then here, and then here. So Taylor's correct. Ed's first name will be Ed. His last name will be Sheeran. And Adele is Adele and Adkins, like that. And then once we're done adding all our objects like that, we'll go ahead and call try mock.save to write it out. So that adds our examples. And now we're going to add 2 more buttons, one to show only the A names, so in this case Adkins, and one to show only the S name, so Swift and Sheeran. So we'll say below that is a button, show A, last name filter is A, and then button, show S, last name filter is S. Now so far this has been pretty straightforward, but now for the interesting part, we've got to try and replace this list of matching singers here with something real. And we're not going to use @fetchRequest here because we've got to be able to make this thing inside initializer somehow to customize it. Because we're changing the state value here, right? And that last name filter will affect our fetch request. So we cannot make a fetch request up here. That would make one property depend on another property, which is not allowed in Swift. So we can't do that. So instead, we'll make another SwiftUI view to handle this filtered list. So press Command N, choose SwiftUI view, and then call this thing filtered list, like this. And then create. Now, this thing will be the one that actually handles our fetch request. And it'll work because it'll pass in the managed object context from the previous view. It belongs to the previous view, so it's fine. So we'll say in here, there's a @fetch request var fetch request is a fetched results of Singer. And that stores our fetch request. It does not create the fetch request. We're making it here so we can use it later on. But we're not making it here because we still don't know at this point what we're searching for, like who we're searching for. Instead, we're going to make a custom initializer in this view that accepts a filter string, look for A, look for S, whatever, and that sets fetch request to be the right thing. So go ahead and add this initializer now. Init with a filter string underscore fetch request is equal to fetch request here of Singer with sort descriptors of an empty array, and a predicate will be ns predicate with a format of last name begins with, one word, begins with %at, then our filter. Whatever the string we've asked for, begins with S, begins with A, or who knows what. And that's going to create the fetch request using the current managed object context. Remember, this view is using the side content view. So it'll get the data from there, it'll get its managed object context, it'll do the right thing automatically. We haven't got to inject one by hand in here, it'll get the one from content view. But the important bit here is that one character on line 18. There's an underscore at the start of fetch request, and that's intentional. Because we're not writing to the fetched result object that's inside our fetch request. We're instead writing a wholly new fetch request. Now, to understand this, think about previously if we had an @state property here called private var score is 0, whatever, right? We'd have a state value here with a score integer in the side. And if we said score equals 10, we understand put that 10 value into the score integer. But behind the scenes, this whole thing, the score, is actually stored inside a different struct called state. This thing here, this property wrapper, wraps up the integer in a new type called state. And that's the one that handles watching for changes and reinvoking the body property and all that kind of nice stuff. Integers can't do that. The state struct does that. In fact, you can right click on here and ask to jump to definition and see it in action. These are all unhelpful. Thanks, SwiftUI. Let's try and state in here. Perhaps I might get lucky. There we go. You can see it in action as a struct in the SwiftUI interface if you want to. It's just there. There you go. Struct state stores some kind of value. And this means it reloads the body when it changes. So when we say score equals 10, we're writing the modifier. We're saying, hey, put this 10 into the integer, right? But we can also write to underscore score. Underscore score. And that means I want to touch the state object directly, the state wrapper itself. I want to make a new wrapper on a different integer. I suppose I'm just changing the current integer, they're the same wrapper. Anyway, by assigning here to underscore fetch request, we aren't saying, here's some new results to load. Like, we're not giving it new results to show. We're saying, change the whole fetch request itself. Now, at this point, all that remains is to write the body property. So we'll say, there's a list of our fetch request with the ID of \self, one Singer coming in. We'll do text. And then quotes, let's get this right, Singer.wrapped first name, like that, and then Singer.wrapped last name, like that. So show Taylor Swift, Adele Adkins, Ed Sheeran in each row like that. As for the preview, you can just zap that. It's not required here. Okay, so now we have our little filtered list view, which understands, give me a filter string and I'll do the check for you and load back the correct data. And now back in content view, we can go ahead and use that for our list of matching singers. We can say, show a filtered list here, with the filter being our last name filter. So it's A right now, but it could be S in the future. Go ahead and press Command R to build and run your code and give it a try. Make sure you start by pressing Add Examples, like that. We're only seeing a del right now because the default value of filter is A. But change A to be S, and you'll see it jumps between the two correctly. So it's the same ultimate view showing the list, but the filter inside is changing dynamically now. So it took a little bit of new knowledge to make this work, right? You have to know how to use the underscore, for example, to poke around in the actual fetch request object, not the fetched results inside it. But it really wasn't that hard. And as long as you think like SwiftUI, you're most of the way there. Now, you might look at this code and think, well, wait a minute. This initializer is run every time the view's being recreated, right? Which is every time any state changes, right? Whenever we change between A and S, A and S, A and S, that code will run, okay? But that also in turn means, well, we're changing the fetch request every time as well, from A to S and A to S and A to S, which seems disastrous because that would mean we're reloading the data every time we're changing any state in our view. There's some other thing happening, like a counter changing 1, 2, 3, 4, 5, unrelated to our filtered list. It'd be reloading our data every single time. And that might sound wasteful. And honestly, it would be wasteful if it actually happened. Fortunately, core data will not do that. It'll do nothing like that. It'll only actually rerun the core data request if that state has changed. It's smart enough to know, aha, I've got that already, and just put it on through, even if the view's being recreated. As long as the actual sort filter the predicate filter hasn't changed, it won't change it. Now, at this point, you know everything you need to know. But if you want to go further, for more flexibility, we can actually improve our filtered list view so it works with any kind of entity. Because right now, it works with singers. And actually, you might want to use this elsewhere in your code for any kind of data. To do this, we can no longer refer to singer here. We're going to use generics with a constraint saying you can give me any kind of object as long as it's some kind of NS managed object, because that way core data can use it. We'll then have a second parameter inside our initializer here to decide which key name we want to filter on. So we can't always use last name here. That doesn't work, right? If it was starships or chocolate bars or who knows what, last name wouldn't make sense. So we can't always use last name. And now, because we don't know what each entity is going to contain, we'll let our parent view, our container view, decide. So we can no longer have show a text of wrap first name, wrap last name here. We'll just say, hey, whoever controlled me or contained me, created me, that's the word, whoever created me, you tell me what should be in each row. And I'll just say, here you go, here's a singer, what do you want to do? So it'll do the right thing automatically. There are two complex parts in there, which is why you don't have to be here. You can stop the video, skip on to the next one, and you're perfectly happy. But there are two complex parts here. First is the closure that will replace this code here, right? That will say what should be in each row is complicated because it's got to use two important pieces of Swift syntax you haven't seen before. We've seen them, I think, briefly previously, but only in passing. One is @viewBuilder, which lets our containing view send in multiple views if it wants to. Here it's one, but it could in theory be who knows what. It's down to containing view to decide. The second one is @escaping. We're going to say the closure you give us won't be used now. It'll escape our initializer and be used later on in our body, which is why it's escaping. That's part of it. The second complex part is how we let our views customize our filter key, because right now we have last name, it begins with %@, right? So you might say, okay, let's take an educated guess here and say %@ begins with %@, and then use something like key name and filter. but that's not going to work. We haven't defined key name for a start, but we'll do it in a second, obviously. It won't work because when you use %at, core data automatically inserts quote marks for us, so it reads correctly. If you remember, it begins with S or universe equals Star Wars with the quote marks. It does that for us when we have %at, so we can't use that here. And so we'd end up with something like, last name equals %at, whatever, which is not what we want. Like, that bit's fine, this bit is not fine, so we can't do that. So the attribute name should not be in quotes, and so %at is not the right solution here. The actual solution, again, you couldn't guess this is just how it works, is called %k. %k. And that will insert the values we provide still, it'll insert key name in this case, but it won't add quote marks around it. Okay, let's go ahead and undo it for a second and get back to where we were when it all worked. There we go. Okay. Let's introduce our upgrades here. We'll say our filtered list thing here is now generic over some kind of T, but it must be an NS managed object. Now you've got to insert your core data here, making sure it's happy. Some kind of managed object, but also the content of our list, the rows, will be some kind of view content. So we'll say, you got to give us some kind of content, but whatever that is for the row, it's got to be some kind of SwiftUI view, right? So you've got to give me a managed object to work with and a SwiftUI view to lay out inside your list rows. Inside our thing, we have the fetch request here, var fetch request, fetch results. We don't want to use Singer anymore. We want to use whatever they asked for. Whatever this T was up here, whatever managed object they want to work with, that's the one. So we'll just put in T here. Next up, this content for our list rows. What do they want to show in there? Now we know it's going to be some kind of content, which is whatever view they've passed in. So we'll say in here, you've got to say, give me some content closure, which will accept a T and return some content. So we're saying, I will give you, as a parameter to your content closure, whatever is your T. Here's a singer. Here's a chocolate bar. Here's a employee. Here's a starship. Whatever it is. Whatever you've made this with, I'll give you one of those. And it's your job to give me back some content to show inside my list. And that, again, must be some kind of SwiftUI view. So I'll give you a T, give me back some content like that. Inside our list here, we're going to list fetch request ID self. One item comes in. We don't know what it is anymore. We can now call our content closure passing in that item. So you've given me one singer, one chocolate bar, whatever. I can then pass that to the function you provided earlier, this content closure. Here's the item you asked for. Boom, here's one singer. Give me back the correct thing to lay out. And that's what this code is doing right here. Now we're going to upgrade our initializer here. So we'll have our filter key is a string now, and also our filter value is a string now. That's the easy part. The harder part is how we pass in this content. Now remember, at its simplest, we would say this content is a function that accepts a T and returns some content. That's the easy version. And we can just do, self.content equals content. But that's not going to work because it's actually warning us straight away. This is a non-escaping parameter assigned to an escaping closure. So what we're saying here is we're trying to stash away this function for later on to be used up here. We haven't told Swift that. And Swift by default assumes you use the closure immediately inside the initializer so it can not have to worry about memory management. It does an immediate call and move on. We're stashing it away. Keep this alive for me for later on is what we're saying. We've got to tell Swift that. We've got to say, actually, this thing will be an @escaping function. It's going to be used later on, not now. And like I said, the finishing touch here is to also use the @viewBuilder attribute, which is what most SwiftUI uses, things like VStack and lists and all the other types here, and they mean you can provide many views in here if you want to, and we'll do the right thing. We'll get tuple view of 0, 1, 2, 3, whatever you want to. So a view builder here is a finishing touch. Now for our fetch request, we don't want to have a fetch request of singer anymore because it's not singers. We'll do a fetch request of T. So whatever type they've asked us to work with. Then the sort hasn't changed. The predicate though, we don't want to use last name begins with %at. We want to do %k begins with %at. And now pass in both filter key and filter value like that. And now with that in place, we can go back to our content view and use the new filtered list. So a filtered list now, we're going to provide a filter key. We'll say, give me last name. And filter value will say our last name filter. But we're now going to provide a trailing closure. It will give us one object back. What do you want to do with it? So we could say, I want to have, let's hide this left-hand bar to make some space. I want to say, I want to have the text of singer.wrapped first name and then singer.wrapped last name, like that. But where did singer come from? And this is passed into us, remember? We could just say singer in. It'll pass us one object from the list, and it's our choice of how to decide what we do with it. However, that code is not going to work. As you can see, it's complaining. It says you've got an NS managed object back, not singer. Now, obviously, singer, our entity type that's made for us, comes from NS managed object. But we have to tell Swift that. We have to say this singer is actually going to be a singer class. It's going to know that. So we'll just say this thing here, you expect one singer coming in. That's what you'll get. And that's what makes the whole of our code work, because now it knows it's a singer. This T becomes singer. Therefore, the T here becomes singer, and a T here becomes singer, and a T here becomes singer. Everything else becomes a singer. It knows our content closure must accept a singer object, and that's why we can read wrapped first name and wrapped last name. So that extra information, singer is a singer, is what tells Swift, yeah, this is how filtered list is being used. Let me access the data as if it were a singer here. Now remember, this can handle any kind of NS managed object. So in your own code, you can reuse filtered list to handle any other kind of data now. It's really, really flexible. It'll handle any kind of filtering, any kind of filter key. It's really, really nice. Anyway, that in place, press Command R if you want to. It should give us exactly the same result. So there's Adele and there is Taylor and Ed. It hasn't actually changed, but it's much more flexible and therefore much more useful too.